Hi Math 95. In this video we're going to finish section 11.1 by talking about the distance formula and the midpoint formula. So when we're working in the xy axes, working with coordinates like x and y, we can use a couple of formulas to find the distance between any two points in the xy axes, right? So for the distance formula, first of all, if we want to find the distance d between two points, let's call them x1, y1, and x2, y2. This is just special notation so that this denotes one ordered pair and this denotes a second ordered pair, right? That's the little subscript notation here. First ordered pair, second ordered pair. If we're working in the rectangular coordinate system, that just means the xy axes. So we make use of this crazy looking formula right here. The reason we're doing this now is because this is making use of a radical and we just worked with radicals. This distance d, by the way, is always going to be a positive number, right? So we're only looking at the principal or positive square root here. So let's do an example and find the distance between 2 points, and then after that we'll talk about the next thing, which is the midpoint formula. So let's work with these 2 points right here, -1, -3, and 2, 3. And let's find the distance between them, right? So find distance between. Okay? So quite honestly, it doesn't matter which point you label as x1, y1 and which one you label as x2, y2. It doesn't matter, just as long as we follow the formula listed, right? So let's maybe label the points here just so that you can see. You don't have to do this part, but I'm going to label them so you can see what values are coming from where, right? So I'm going to label this as x1 and y1, and I'm going to label this as x2 and y2. Okay? Now let's make use of our distance formula here. So it says that the distance d is equal to a square root, a big square root, because we're going to write some subtractions and squaring and stuff. We do x2 minus x1. This is just the difference of the x's, right? So x2 is 2, right here, minus x1, which is -1. Okay, and then we'll square that thing according to our formula, plus we do y2 minus y1. y2 minus y1 squared. y2 is 3 minus y1, which is -3, and we square it. And that all lives underneath the square root symbol. So now let's follow order of operations to simplify the inside. So this is really 2 plus 1 squared plus 3 plus 3 squared. And so now this is really what? Square root of 2 plus 1 squared, which is 9, because it's 3 squared, plus 3 plus 3 is 6, and 6 squared is 36. Make sure I did that right. 2 plus 1 is 3, 3 squared is 9, 3 plus 3 is 6, 6 squared is 36. So this is the square root of 45. And that's our distance. Notice that is not a simplified radical, so let's try simplifying that radical. Notice that 45 has a perfect square living in it. It is 9 times 5. So that means that the distance truly is what? The 9 will be acted on by the square root and come out front as a 3. So 3 square roots of 5. And then I don't know what we want to say in terms of the units are here, but in the rectangular coordinate system, you can just say units, right? So the distance between those 2 points is 3 square roots of 5 units. The distance formula, by the way, comes from the Pythagorean theorem. If you notice that if you squared both sides of this equation, you would get d squared equals difference of the x's squared plus difference of the y's squared. That's exactly the Pythagorean theorem when you're working with a triangle that connects the 2 points in the xy axes, right? So if you took 2 points, here, and you wanted to find the distance between them, let's choose a color. You wanted to find the distance between them, what you could do is measure how far apart they are in terms of x, and you could measure how far apart they are in terms of, in terms of y, and that's a little right triangle like that. This right here is the difference of the x's. That's x2 minus x1. This right here is the difference of the y's, y2 minus y1. And by using the Pythagorean theorem, we see that this side squared, plus this side squared, plus that side squared, is equal to that hypotenuse squared, right? So here, if this was d squared, we would have d squared equals x2 minus x1 squared plus y2 minus y1 squared. That's just the Pythagorean theorem acting on that right triangle right there, where the distance between the 2 points is the hypotenuse of that right triangle. Okay, let's use these same 2 points and find the midpoint between those two. So the midpoint is going to be the point halfway between the two, right? So if we were working in our triangle right here, these aren't necessarily our 2 points, but let's say we had our 2 points, right, which were these little end ones right here that we were given. The distance between the two is the length right there labeled D. The midpoint between those two would be the point halfway between, right? So that would be like this dot right there. Oops, silly little marker thing right there. Yes, we'd like to know how do I find that little midpoint right there. We make use of a formula again. So let's turn our page here and we will use a new formula. So let me copy down our points again. They were -1, -3, and 2, 3. And the instructions would say something like find the midpoint between the 2 points or something like that. So how do we use the formula? So again, we have this notation for x1, y1, and x2, y2. Again, it won't matter what you label the points as. This could be x1, y1, and this could be x2, y2, or vice versa. It doesn't matter, as long as you understand what the formula is saying to do here. Notice that in the formula here, it gives you an ordered pair as your answer, because your answer should be an ordered pair. Notice, if we go back a page here, the midpoint should be what? An ordered pair. It should be a point in the xy axes, right? The distance should not be an ordered pair. It's just a length, right? That should be just a real number. The midpoint, however, should be an ordered pair, which is why our formula over here gives us an ordered pair. And how do we find the coordinates of the ordered pair? Well, to find the x coordinate of the midpoint, you do what? Average the x values of the points you're given. That's what an average is. Add them all up, divide by 2, right? And to find the y coordinate of the midpoint, you do what? Average the y values of the 2 points you're given. Okay, so our midpoint is going to be an ordered pair, and it's an ordered pair where what? The x coordinate is given by doing what? Remember, you just average the x values, right? So we average the two x values we have. The x values were -1 and 2, so I averaged them, -1 plus 2 over 2, and now I average the y's. Okay, -3 plus 3 over 2. So our midpoint then is what? -1 plus 2 is 1 plus, yeah, -1 plus 2 is 1 over 2, so 1/2. -3 plus 3 is 0 over 2 is 0. Okay, so that is the midpoint of the line segment, or the line, the piece of the line, which would connect these two endpoints right here, right? Excellent. That finishes up 11.1. There will be another video for 11.2.